Okay, so this is a little bit of a longer video, but I want to walk through the actual inspection method, doing the auto scan, auto inspect, and auto report. So we've got the system set up here. We're back at Optotec in Frankfurt, Germany. And you go ahead and enter all of your part information. You can have file name, part number, serial number, some kind of description, and of course you want to enter the side. You can then set dynamically, or you can just manually enter the map information, whether it's rectangular or it's elliptical. And I'll go ahead and make it an elliptical part. We'll make it 39, I think it's 39 or 40 millimeters, I'm sort of guessing, but that should be good enough. And we get this surface map, and now as with all our older products, you can actually make your surface map and populate that with imperfections manually. But what's been a lot of fun is working on the automated version of that. So we can click OK, the map now exists, and we have to tell the software where 0 is. So for an oval part, 0 is top dead center, so I say OK. And I'm now all set to do an inspection. So I'll go ahead and hit auto scan. And the software will now, because it knows the part geometry, it will step across the part, grabbing successive images. This is a 9 by 12 millimeter field of view, but the uniformity of the illumination that's good enough to do inspections is only about 5 millimeters by 5 millimeters. So we're grabbing 5 by 5 millimeters, or 25 square millimeters per second off of that part, and we're storing that in a very big data file. And it's going to continue stepping across the part and grab all of those images, and then it will stitch those all into a single tiled image. You can actually pause the scan while you're walking across the inspection if there's something of interest that you think you might want to get a picture of. For example, maybe I want a picture of this funny imperfection here. I can enter information about the part and give it a label, and it will go ahead and add that to my surface map down here. And then I can go back to scanning, and it just remembers where it was. It doesn't disrupt the auto scan at all. So that gives the inspectors a different way to operate the machine, because you can now actually scan 100% of the surfaces and pause and grab images of whatever you're interested in, even without using auto inspect and auto report. That's just based on the auto scan itself. That feature is standard for all of our motorized units. You don't need the automation package to do that. So that's kind of a handy way to do a motorized assist manual inspection, and that's been popular in the US. It does take a little while to do a scan, so this is a 40 millimeter roughly diameter part, and at 25 square millimeters per second it takes about 2 minutes to complete the scan itself, maybe even 3. Usually the stages are running a lot faster than this, but today I have slowed the stages down because the table is not quite so stable, and when it jitters around a lot, it actually messes up the auto scan. So we'll have to be patient, wait for the scan to finish. While we're waiting, you can see we've got these 3 mode buttons up here, and you'll notice that there's mil visibility, ISO visibility, and ISO dimensional method. Right now we're doing the scan in mil visibility mode, but of course ISO visibility is another norm that might be used for these kinds of optic specifications, and ISO dimensional is based on the old DIN 3140 dimensional method, and we have other videos that explain how that works. So what's happening in a routine inspection, of course, is any imperfection showing up in the 1 square millimeter box, the measurement window, winds up going through 2 pipes. The first pipe is determining the scratch grade. The second pipe is determining the dig grade. Now here we have the finished auto inspect. So this is our auto scan here, and we're going to go ahead and mask out all this edge data, because the software doesn't know that that's not a scratch. So we'll just carve out the clear aperture for the part, and then there's some settings that we can use to decide how aggressive we want to be about accumulating different imperfections. Once we've set those settings, the filters, we can go ahead and find defects, and the software will interrogate this very large file to find how many imperfections it has for scratches and digs. And you can see that we've got quite a few scratches on this part and quite a few digs. But we'll go ahead and analyze them. So now the software is going to go back to its original mode, and it knows exactly what the coordinates are for every scratch and dig on the part. And it's going to move to each of those scratches, and it's going to check them to see what the brightest point is for the mill standard, or the widest point for the isodimensional method. And for digs, of course, it would just evaluate the square root of the area for isodimensional mode, or in dig mode, or in mill mode, you would just be looking for the apparent dig diameter according to the mill per 1330B. So it's wandering around making all of these measurements now. And there are 47 scratches, so this will take a few seconds, maybe a minute. The digs would take about the same amount of time. And you can see most of the scratches that it found are actually below the number 10, so they're not reporting any grade at all. It found those scratches, but they're really below the 10, so we would ordinarily not report them. So that means that I would probably reset my filters if I was going to do a large batch of these parts to eliminate a lot of these scratches that I ultimately don't care about anyway. Or if I just want to collect all of these little minor sleeks and make sure I know where they are, I can just leave these filter settings as they are. The software is about half done right now with the scratches, and obviously with so many scratches it takes a lot longer. You can actually watch the progress of the auto inspect with the little white cursor. The white cursor tells you where you are on the part at that moment, and you can also populate that, as I said before, with manual surface imperfections that you've located. There's a pretty gross one right there, for example. So I might want to pause the inspection, grab some data, and then resume the inspection again. You can actually follow the position of the cursor here as well. Every time it goes to a different location, it's going to report what the coordinates are of that imperfection, and you can see it, of course, down here on the dynamic model as well. Almost done. We know we're getting close because there's a really big scratch at the bottom. That's a number 80 scratch, which is about 25 microns wide, we know, because we looked at it just a minute ago in the isodimensional mode. So now it says, okay, I'm done with all the scratches. Do you want me to do the digs? And just for time, we're going to go ahead and just skip the digs and only show the scratches report. And there we go. Now we're back to the screen where it shows a map of all of the imperfections. So these two are equivalent maps. We know that this imperfection we looked at earlier is right there, and all the other imperfections are identified in our map. Each one is flagged and includes a stored image of the imperfection that it grabbed. We can look at some of these bigger ones, and as I click them, of course, it's finding the imperfection in the map itself, or I can just wander around on the map and look at whatever imperfections I want to see. So there's that big number 80 scratch towards the bottom, and we can click on it, and that is this guy here, and scratch number S47 in this case, a number 80 scratch, 3.2 millimeters long. So in this case, although there's a lot of scratches there, they were real faint, and with a scratch spec of 8050, the part would pass. Of course, if the scratch spec were tighter, the part may fail. So you have your auto inspect with this screen. Auto report gives you exactly whether or not it passes or fails, and then I can go ahead and print that and send it to the customer. So there you go. So that's auto inspect, auto report, live from Optitec. Hopefully this video is helpful. Thanks, take care.